Hello and welcome to Exponents 4.3, and today we're going to solve for x, and this is just like the previous section in the sense that we're going to solve for x, but x is an exponent, but the way that we solve it is not going to be the same because in the last lesson we made the bases match on the left side and the right side. Yeah, but today there's no way I'm going to turn 42 into 6 to the power or something. It's not a nice number, so we're not going to do that technique. Okay. So the technique we're going to do instead is going to take us back to section 2.1, 2.2, where I had to change forms. So right now we're in exponent form and we're going to change it to log form. Okay, and when that happened, this is what I normally did when I did the lesson. I labeled the names of each of these numbers and letters as far as what the location is called. Yeah, so I called 6, I called him base, I called the x the exponent, yeah, and I called the 42 the answer. Yeah, and I'm gonna just switch forms. Yeah, I'm gonna switch it into log form. So in log form, it starts off with exponent equals. So I write x equals because x is in the exponent spot, so I write x equals. Then I write the word log. And then the little tiny number base goes next to the g. So my base is 6. I write a tiny little g right here. And then inside the parentheses, I put 42. Okay, so here's what happened. Yeah, but you notice how x is by itself. Yeah, so what we did was we switched forms. We took advantage of a technique we had in 2.1, 2.2. So we switched forms, and x is by itself. X is no longer written tinier, raised above the 6 as like an exponent. I mean, it still is exponent because this is log form and that's called exponent, right? But it's not our typical exponent that we normally see in a normal problem. So therefore, we can solve for x. Yeah, and when we solve for x, if you don't have an advanced calculator, that doesn't let you put whatever number in this base position for a log. Yeah, you might have to use change base formula, which is x equals log of the answer, so log of 42 basically, divided by log of the base, which in this case is 6. Okay, and when you do that, yeah, you're going to use your calculator. Yeah, if you don't have your own scientific calculator at home, you can use your phone, or you can go to desmos.com. Yeah, and when you guys use your phone or desmos.com and you punch it all in, you're going to get x equals, and you're going to get a big number with a decimal. So 2.0860 33133. Okay, so you guys got to really watch out for your rounding because you guys are not listening to your directions as far as rounding is concerned. Yeah, so this thing says round to 4 decimals. And a lot of you guys are ignoring that, so you got to stop that, please. Okay, look at your directions. So who's currently sitting in the 4th spot? 0 is. Okay, so 0 is sitting in the 4th spot. So he looks at 3 and says, 3, do I stay a 0? Or 3, do I turn into a 1? Yeah? And here's how you can remember how to round. If the 5th number, the one right after the one that you want to round, which is the 0, if he's 0, 1, 2, 3, 4, you stay the same number. If he's 5, 6, 7, 8, 9, you turn it into the next number higher, which is a 1 in this case. So since my 5th number is a 3, 0 is going to stay a 0, so you just write your answer as x equals 2.0860. And that's it. This problem's done. Okay. All right, so let's go on to number 2. Okay, so number 2, same way, right? We want to solve for x, which is in the exponent spot. So 3 is my base, x is my exponent, and 14.5 is in the answer spot. Yeah, so when I switch forms, it's going to be x equals log base 3 of 14.5. Right? All I did was I changed forms based on the section 2.1, 2.2. So if you forgot how to do this, then just go back and watch the 2.1, 2.2 videos. Okay. So once again, we're in that territory where if we don't have that advanced calculator, right, the one that can actually just put whatever number I want inside that base position, then you got to use change of base formula, which is really easy. It's not that difficult. You just got to make sure you know what to put on top. So log of the answer, which is 14.5, right? Answers whatever's in that parentheses, divided by log of the base. And base is that tiny little number right next to the g. Okay? And when you plug it into your calculator, you're going to get 2.4341 and 14999. So who's sitting in the 4th spot? The 1 is, so the number right after it, which is the 1, says 1, do you stay a 1? Or 1, do you turn into a 2? and the fifth number tells the fourth number, stay on 1. So your final answer is x equals 2.4341. And you're all done. Okay. All right, let's look at problems 3 and 4. Okay. Well, actually, number 3. Sorry, not 3 and 4. 3 first. Okay, so we're gonna do a couple of steps first before we change the form to log form. Yeah. And when I do these couple of steps, you're gonna say, wow, this looks just like solving for x, where I just gotta get rid of things by adding and subtracting or multiplying and dividing. Okay, so I have 20 times 1.05. Actually, I should put this in parentheses, and it'll make it easier to see how I'm getting things away from the 1.05 to the x power in the parentheses. Okay, so I'm gonna do things that are very familiar looking, right? So I'm gonna say to myself, do I divide by 20 first, or do I add 5 first? Yeah, and I want to make sure I get the parentheses with the power of x all by itself, so I can make it look like problems 1 and 2. Okay, so hopefully you responded with add 5 first, so I can make the negative 5 go away. So add 5 both sides. Then I get 20 times 1.05 to the x power, and the reason why I put the x inside the parentheses is just to tell you guys that it doesn't matter where the x is. It can be inside the parentheses, it can be outside the parentheses, right? Because the x is only controlling the 1.05. It's not controlling anything else. So if you want to put it inside or outside, it doesn't matter. Yeah, so I kind of did that on purpose to show you guys it doesn't matter where you put the x in this particular problem. Okay, then that equals 40. Okay, so next I want to get rid of the 20, so next I'm going to divide by 20 on both sides. And then I get 1.05. And since there's nothing surrounding the 1.05, I can just get rid of that parentheses, and then equals 2. Okay, so now this problem looks exactly like the ones that we just came from on the previous slide, right? Where I can call the 1.05 my base, x is my exponent, 2 is my answer. Yeah, so this is going to be it's just now just pretty much turned into the problem we just came from on the previous slide. Yeah, so I'm going to rewrite the form. I'm going to go x equals log of the base, which is 1.05, of the answer. Okay. All right, so then this next step should also look familiar, right? You're just going to turn it into change base formula, where it's log of the answer, which is 2, divided by log of the base, which is 1.05. And then I'm going to punch it into my calculator, and it's going to tell me that the full number is what is number 3? 14.2066 9908. Okay, so who's sitting in the 5th spot? So 6 is sitting in the 5th spot. So the 6 is sitting in the 4th spot. The 9 is sitting in the 5th spot. So the 9 tells the 6 stay at 6, or does 9 tell the 6 to become 7? Yeah, and hopefully the message that you got was turn into a 7. So this, when you round it, will become x equals 14.2067. Okay, and like I said again, don't forget to round, because all you guys, not all you guys, but a lot of you guys are forgetting to round, and like having to write it in the comments like the whole time, like, oh, that's not how you do things, people. Okay, so make sure you guys round. Okay, all right. So let's move on to the next one, number 4. Okay, so it's very similar to the previous problem. We got a multiply by 7 that's in the way. We got a subtracting 11 that's in the way. So we got to get rid of those two things first. So hopefully when you guys tell me what to do first, you say, let's get rid of the negative 11 first. But let's just write the problem first of all. Okay, so 7 times 1.3. And ooh, look at this power. This power is kind of not your typical power. Yeah, it's 5x minus 2. And once again, you're going to say, does it matter where I put the 5x minus 2? Yeah, you put it outside, you can put it inside. It doesn't matter. Yeah, because the only thing that 5x minus 2 is controlling is the 1.3. He's not controlling the 7. So please don't make the 7 be affected by the 5x minus 2 power. Okay, if you do that, then you're going to make a big mistake. Okay, so let's take away this negative 11 and the 7. So we're going to take away the negative 11 first. So we're going to add 11, both sides. And we're going to get 7 times the quantity 1.3 to the 5x minus 2 power equals 28. Okay, Then we're going to get rid of the 7 by dividing both sides by 7. And then we're going to get 1.3 to the 5x minus 2 power equals 4. Okay, and this turns out to look like just like the previous problem we just came from, right? So let's say I need more space. So we're going to change form. So 1.3 is my base, 5x minus 2 is my exponent, 4 is my answer. So I'm going to switch to log form. Okay, 1.3 is your base, 5x minus 2 is my exponent, 4 is my answer. So I'm going to change it into log form, which says, write your exponent first, 5x minus 2 equals log, and then the tiny number right next to the g is going to be your base, which is 1.3 of the answer, so 4. Okay. All right, so this is a little bit different from the previous problems also, because in the previous problems on that left side we had just regular plain old x. Yeah, we didn't have a 5 that was multiplied to the x. We didn't have a minus 2 either, so we're going to have to do some extra steps this time. Okay, so actually I'm just going to push the steps all the way to this right side already, because I know I'm going to need space. So let's just write the same thing again. Actually, let me write it in change of base form on the right side. So change of base form says log of the answer, which is 4, divided by log of the base, which is 1.3. Okay, how come that 4 didn't write fully? It's like you got cut off at the bottom. Okay, all right, so we're going to use the calculator. We're going to turn the right side of that equal sign, the log part, we're going to turn it into a decimal. And we're going to get 5.2838. 53.59. Okay, so here's where kids make their mistake when they reach this problem. Yeah, and the ones that are going to be just like it on the homework. They see the decimal and right away they're going to say, oh yeah, Ishikawa, he was telling us do the rounding, do the rounding, do the rounding. Yeah, so they're going to turn the 8 into a 9. No, you do not round yet, because this is not the answer yet. Okay, this is not the answer yet. So please do not round just yet. Okay, you gotta wait till the very, very last number when x is all by itself before you round. Yeah, because if you round too early, your answer is going to get slowly and slowly more and more inaccurate. So you want to save the rounding for the very, very last number when it says x on the left side equals just your decimal number on the right side. So the 5 and the negative 2, we got to get rid of them first before we can round this decimal. So we're going to keep that big ugly monster intact the whole way through the rest of this problem. Okay, so what do we do next? Do we get rid of negative 2 first? Or do we get rid of 5? And hopefully you say get rid of negative 2. And I do that by adding 2. Okay, so it's easy. Yeah, adding 2 to a decimal is really easy because the decimal is not going to change. Only the number in front of the decimal is going to change. So we're going to get 5x on the left. And all the decimals on the right side are not going to change. This 5 is just going to turn into a 7 with the same exact decimals. 2, 8, 3, 8, 5, 3, 5, 9, 2. Okay. All right, and then to get the x by itself next, we're going to get rid of the 5, and the only way to do that is divide by 5. So divide by 5 on both sides, and we're going to get x equals, and this is where your decimal is going to change. Okay, you're not going to see the same numbers anymore. So you divide by 5, we're going to get 1.45, 677, 0718. Okay, so who's sitting in the fourth spot? Fourth spot is a 7. Fifth spot is a 7 also. So the 7 tells the 7 to turn into an 8, or does 7 tell the 7 stay a 7? Well, based on your rounding rules, the fifth number, 7, tells the fourth number, 7, to turn into an 8. So your final answer is going to be 1.4568. And we're done. Okay, I think that was the last problem. Yeah, that was the last problem. Okay, so I will see you at question and answer, and good luck on the assignment. Bye-bye.